Ouch. That's a lot, by the way.
Mr. Diaz told the student that the sum of the digits was 14 and agreed to get the correct score plus extra credit if he could determine his actual score without looking at his test. What was the actual score on his test?
Okay, so the problem here was this student got a grade, and Mr. Diaz, when he put him into the system, instead of putting, for example, let's say 86, he put 68. Is that a difference? Yeah, it does affect, and I've done that. I've switched digits on someone's. Some of them I've caught. Some of them, oops, yeah, you didn't get a major F. You got a high B. So that's a big difference in scores. So in this case, Mr. Diaz told them the sum of the digits was 14, and if the student could figure out his original score without looking at the test and what Mr. Diaz wrote, he'd give him bonus points. So that's kind of a nice little deal. Let's look at something with numbers first. So this is still lesson 8-4. I'll call it 8-4B. And we're dealing with word problems with systems of equations. Oh, it's recording. Good. All right. So let's talk about digits and place value, okay, because we need to understand this very well. Can somebody give me, listen carefully, a two-digit number that has two different numbers for each digit? So don't give me like 11. I don't want 11. I want a two-digit number with two different numbers. Yep. 39. Okay. So go ahead and write the number 39. Okay. This is actually more important than we actually think. I know you know what the meaning of 39 is, but do you know the actual place value meaning? And this is what I mean. First of all, 9 is in which place value? You guys remember what that? Okay, the ones place. Have you heard of it as the units place? Have you ever heard of it units place? Okay, that's another way to put it, and I'm going to call it the units place. It just means the ones place. So 9 is in the units place. What is the 3? What place value is the 3 in? Tens place. Guys okay with that? So those are place values. These problems can get into the 3 and 4 digit, but we're not going to get into that. So we're just looking at a 2-digit problem. Okay, the value of 9 is based on which place value it's in. So what's the value of this digit 9? It'd be 9 times its place value. What's the place value? Units or ones place. So what's 9 times 1? 9. Okay, so that's pretty... there's no change there. It's pretty understandable. It's where you start getting further out. 3. Is that just worth 3 right there? No, it's actually worth 3 times 10, which is 3 times 10 is 30. And what's 30 plus 9? 39. So back to our original problem. Do you guys see that the way we use our system is we use how many digits? Do you guys know how many digits we use in our system?
Infinite.
No. It's a set number.
5.
Nope. Think of it.
1.
Digits. You use
1.
10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are your digits? You guys remember that? Do you know why we call it the decimal system? Because how many digits do we use? Deci means what? 10. So that's what we're talking about. This is important for these problems because then when I start writing these equations, you're going to be like, wait, why do you put 10? Why do you put 1? Well, it's because of the place value. Give me another 2-digit number with separate or different digits. Yeah.
36.
36. All right, 36. Can somebody tell me what the 6 is worth in this place value? What's 6 worth? What's 6 worth right here? Not a tricky question. It's worth 6. What's the 3 worth in this place value? 30. Okay? Pretty good? Okay. I'm going to write something here that I hope is not too confusing. So we said this is worth 30 and that one's worth 30. Thank you for the same digit, but you can also say it's 3 times 10, right? Can you do that? And you could have said, if you want to be super clear, that it would be 9 times 1. Right? 3 times 10 is 30. 9 times 1 is 9. We're good with that. On this number, 30, how did we get that number 30? Well, it was a digit times its place value. So 3 times 10 is 30. And then what's the worth of this 6? Well, it's 6 times its place value. And 6 times 1 is 6. Okay? You guys okay with place value? A little bit? Like, oh, okay, I see what you're saying. All right, now we're going to move into our word problems with reversal of digits. Okay. Luis Diaz discovered while entering test scores into his computer that he had accidentally reversed the digits of a test and shorted the student 36 points. Do you know what the actual score is? Do you know what the score was when they reversed it? All I know is this, that the actual score minus the written score has a difference of what? 14. 36 points. Like, they actually should have gotten this, but they put this, and that's 36 difference. And then do you guys notice anything about the sum of the digits? What does it say about this? 14. Okay, ready? Let's look at example 2. And we're going to come up with 2 equations. One equation, super easy. Enjoy it. It's good. The second equation, a little bit tougher. Okay. The first equation is the sum of the digits. I'm going to call the tens digit t. So I'm defining my variables. Have you heard of that? Defining a variable. So you pick a variable, and what does it mean? T means tens digit. And I'm going to call the units digit u. And you can remember that as, and I think it's tens digit, units digit. Okay, so T and U, that's what I'm talking about. You guys okay? All right. What is the sum of the tens digit and the units digit? 14. So ready? Here's my first equation. T plus U equals 14. That's a nice one. You guys see it? The tens digit plus the units digit is 14, the sum of the digits. The second equation is a little bit tougher, but let's see if you guys can get this down. I'm going to write this on this problem, but in the future problems I won't write it down. Let's see if you can hopefully remember it. The original number, I'm going to call it the orig number. Okay, the original number was this. It was 10t plus u. Do I know what those digits were? No. That's what we're trying to find out. But wasn't it whatever the tens digit was, you multiply it by 10, and whatever the units digit was, you multiply it technically by 1. So, okay. The new, we're going to call it the new number. That's the number that's wrong, by the way. The new number had what with those digits? You guys remember what it said? The digits were
14.
It says the digits were reversed. So instead of putting the tens times 10 and the units times 1, this is what Mr. Diaz accidentally did. He did the tens times u, 10 times u and 1 times t. He flipped the digits around, gave them a totally different score. That was not correct. Okay, so this is all my info right here so far. What was the difference of the two numbers? What did he short him?
36.
Okay, ready? This is a tough equation, but I hope you can get it. I know that the original number, 10t plus u, and I'm going to put in parentheses for a reason, that number, whatever it's worth, minus the one that Mr. Diaz put, the new number, 10u plus t, has a difference. What does difference mean? Subtraction. Has a difference of, you guys said it, 36. Was it 36? Okay, good. This is my second equation. And that's a hefty equation. How many of you would agree that the first equation is a lot more simple, is simpler than the bottom equation? How many of you agree? I would agree. This is much more complicated than that. Can I make the bottom one simpler? Like, can I make it simpler before I even try to figure things out? And the answer is yes. Do you guys remember that simplifying an expression or an equation means dropping the parentheses? and adding like terms. You guys remember that? You don't want parentheses and you don't want like terms. Okay, I'm going to start off with dropping the parentheses. What number is being multiplied by this whole thing? 1. Good. So there's like a 1 there. So what property should we use here? Okay, what's 1 times 10t? 10t. What's 1 times u? Yeah, so I have 10t plus u. You know, basically what happened was those parentheses just dropped when there's a positive 1. Now, look here on the second set of parentheses. What was 10u plus t being multiplied by? Negative 1. So what's negative 1 times tu? All right, so wow. What's negative 1 times 10u? Negative 10u. What's negative 1 times t? Negative t. And that still equals 36. So did we make it a little bit simpler? Yeah, we dropped what? Parentheses are dropped. But are there any like terms in there? Yep.
Yes.
Yeah. You see the t's? Can you combine those two together?
Yes.
What's 10t plus negative t, or 10t minus t? 9t. And then you guys see that these two are like terms. What's u minus 10u? Negative 9u. Negative 9u. And what does that equal? 36. All right. All that. Do we have a simplified equation down there? Like, is that as simple as you can get? Technically not. And this is something I want to help you out with, elimination. I'm going to tell you you could use this equation and work it out with the other one. But does anyone notice anything about those 3 terms? What do you notice about all 3 of them? Somebody raise your hand and tell me. Can I, or maybe I could just call on someone. Abby, do you notice anything? Like about these 3 terms. Something special about them. Common with all of them. It's okay. You just think it through. If you don't have it, it's okay. Just do this. If you don't know it, if I call on you, you don't know it, just put your head down. Give me a guess. What do you think it is? I feel like you have it. Just spit it out there. It's okay. You want to move on? That's okay. All right. Next. Turner, anything you see? Okay. Okay, that's part of it. So you gave me something. 9 times 4 is 36. Okay. All right. Rosalind? Okay, divide what by 9? Okay, 36 can be divided by 9. Can these two be divided by 9? Everything can be divided by 9 evenly, right? So, do you guys see that? All right. 9t divided by 9 is? 9t divided by 9 is t. What's negative 9u divided by 9? Negative u. And what's 36 divided by 9? Oh, isn't that simpler to use? Do you think it is or not? I mean,
more simpler than t plus u is equal to 14.
oh, you're saying this is simpler than that up there?
And
Okay.
then you can use
Yeah. This is, okay, I'm telling you right now, if you didn't see this, like you're like, Mr. A, no, I didn't see that. You could use this. You could still use this with that one. But I'm going to use those 2 equations now, and I'm going to see what you guys think about them. So I have t plus u, equals, was it 14? And then t minus u was 4. Is this a system of equations? Like, do the t's equal one another and the u's equal one another? I hope so. So what can you use to solve?
addition.
Yeah, using elimination, you can add the 2 equations. What's t? And this is something I saw in the quiz. What's t plus t? 2t. What's u minus u? Eliminated. And then what's 14 plus 4? 18. And then what do you do to solve for t? Divide by 2. T equals what? 9. 9. Oh, yay, t equals 9. What does that mean? Okay, what did t stand for? If you're looking at your notes above, what does t stand for?
The tens value.
So, do I know part of the number of his actual score or the original number? Yep, it's 9. But how do I find that ones place or the units place? Can you do it? You just guess. Matt, what do you have? What do you do?
I do 9 plus 4 equals 14, and 9 minus 1 equals 4.
Yeah, you plug it into either one of these equations for t. So 9 plus what equals 14? Yeah, 9 plus u equals 14. What does u equal then? 5. Okay, let's see if it works. Is 9 plus 5 equal to 14? Is 9 minus 5 equal to 4? So that works. So what was the student's actual score? 95%. That's pretty high. What did Mr. Diaz put it down as? 59. Is that a difference? Would you be concerned? Oh, no, just let it go. No, I would be concerned. Now, does it really fit the actual word problem that we have? Let's see. The word problem said that sum of the digits was 14. Sum of the digits 14? Okay. But then what else did they say? What did Mr. Diaz short that student? How much? 36 points. What's 95 minus 59? 36 points. That's almost 4 letter grades difference. That's significant. You should tell me if I do that. Have I done that before?
Yes.
Of course I have. And sometimes I catch it, and sometimes you catch it. So I've never had it where no one's caught it. Someone catches it, we fix it. Okay, but the number was 95. So that's the actual number. Mr. A, this was really complicated, wasn't it? Wasn't it kind of complicated? A lot going on? How many of you would agree there's a lot going on? Okay, let's do it again. I'll do it one more time with you guys, and then I'll have you do it a couple times. Go to page 479. We're going to look at number 30. And it says in the instructions, use a system of equations and elimination to solve each problem. I'll say you can use elimination or substitution. Sometimes one's easier than the other. Okay, number 30. The sum of the digits of a 2-digit number is 14. That sounds familiar. Does anyone know what that equation would look like? The sum of the 2 digits of a 2-digit number is 14. Write that in the equation. What would you write? Yep.
10t plus u is equal to 14.
Really close. It's just going to be, it's the simplest equation. It's going to be t plus u equals, that's the first one, t plus u equals 14. That's your first equation, and this is number 30. So that's how you write. That's your first equation. Is that easy to pick up? I hope so. The second equation might be a little bit more difficult, but not impossible. If the digits are reversed, the new number is 18 less than the original number. Find the original number. Okay. Which one's bigger, the original or the new?
The new. The original.
Which one?
The original. 18 less. That's the original.
It says the new one is 18 less than the original. So which one's bigger? The original. Okay. The original number was this. 10t plus u. That's the original number. What's the t stand for again? The tens digit. What does the u stand for? Units digit. Okay. The difference. What does that refer to? Subtraction. What's the other number? How would you write the reversed form of that number? How would you reverse the digits? You literally reverse them. Yep, Carson?
T plus 10u.
Close. You're getting there. What did you say again?
T plus 10u.
Okay, I'm going to go with that. Can I say 10u plus t? So I just flipped it around. And the reason I do that is because all I want you to switch from here to here is what? What got switched? The t and the u. That's all that switched up. What's the difference of the two?
18.
Which one?
18.
Yeah, it says that the digits are reversed, the new number is 18 less than the original. So 18. All right, that's the equation. Can you make that simpler? Okay, go ahead and do that. So here, I get 10t plus u. All that happened was those parentheses dropped. And then here, I have negative 10u minus t, and that still equals 18. Go ahead and simplify that as much as you can. See what you get. Hold on, if you got it. So some of you should be writing something, at least what I have on the board, if nothing else. And then get that into a simplified equation. Okay, your simplified equation should be 9t minus 9u equals 18. That's what it should be at least. Can anyone get it even simpler than that? Because you don't have to, but you can. Maggie? Whoa, that's a lot different. How'd you get that? How'd you get from that to that? It's huge. Are you allowed to divide everything by 9?
Yes.
Yeah. Are you allowed to multiply everything by 1/9?
Yes.
Are those two different?
No.
No. So that's what we're doing. Multiplying both sides by 1/9 or dividing everything by 9. All right, I have my two equations here. T plus u equals 14, and t minus u equals, was it 2? Can you solve that? Can you figure that one out? Yeah, this system of equations, you get 2t equals 16. What does t equal then? 8. Okay, the tens digit is 8. What's the units digit? 6. How do you check it? What's 8 plus 6? 14. What's 8 minus 6? So does it work? Okay. Yeah, and if you want to check with the actual word problem, what's 86 minus 68? It'd be that difference of 18. So that's another check if you wanted to make it.